general solution of homogeneous differential equation. So let's consider this type of a differential equation. This is a linear differential equation of order n, because in this case we have taken the highest derivative of y as a n times, where we have assumed that this is a normal differential equation. Normal differential equation means a naught, a1, a2 up to an, all these coefficients are continuous on the given interval I, along with the leading coefficient, that is the coefficient of highest order derivative is not is equal to 0. For more details on a normal differential equation, refer the link given in the description. Now, if it is a normal differential equation, then this differential equation has n linear independent solution. Moreover, suppose these n linear independent solutions are y1, y2 up to yn. In this case, the general solution is written in this format. So where yx represents the general solution, that is equal to constant into first function, that is the first solution, plus second constant into the second linear independent solution, plus third constant into third independent solution, so on. Since we have an n linear independent solutions, so we will write last as Cn, that is the last constant, into Ynx, that is the nth linear independent solution. Now, before proceeding to how to calculate the differential equation solution, let's understand what do you mean by the solution of a differential equation. So, solution of the differential equation means it is a function that satisfies the differential equation. For example, in this case, we have taken this differential equation. This is the second order derivative and this is the first order derivative. We need to show that these two functions are the solution of this differential equation. For that, how we will proceed? So we will take let y1x is equal to e raised to power x and y2x is equal to e raised to power 2x be solutions of first differential equation. So if it is a solution of this differential equation, means they will satisfy this differential equation. So from here we can say that in place of y we will replace y1 and y2. So first we have y1 second order derivative minus 3 times of first order derivative of y1 plus 2 times of y1, that must be is equal to 0, and for same for the y2, that is y2 second order derivative minus 3 times of y2 first derivative plus 2 times of y2, that must be is equal to 0 if they are the solution of this differential equation. So starting with this one for the first case. So on the left hand side, we need to calculate second order derivative of first function minus 3 times of first order derivative of first function plus 2 times of first function. Now, first function we have considered as e raised to power x. So, y1x, that is e raised to power x. So, y1 prime, that is the first order derivative of e raised to power x, is e raised to power x. Second order derivative of this function is, again we are having e raised to power x. Substitute these values over here. So the value of this one is e raised to power x minus 3 times of e raised to power x plus 2 times of e raised to power x. Now simplify that, you will get is equal to 0, which is your right hand side. So clearly your first function y1x is the solution of the differential equation 1. Same we will proceed for the second function. So we have assumed y2x is equal to e raised to power 2x. So it's first order derivative. So first order derivative of this one is twice of e raised to power 2x. Second order derivative of this one will be 4 times e raised to power 2x. Substitute these values over here. So what you will get? So you will get the second order derivative of this one is 4 e raised to power 2x minus 3 times of first order derivative value is twice of e raised to power 2x plus twice of the given function, that is e raised to power 2x. Simplify this. This is a 4 e raised to power 2x minus 6 e raised to power 2x plus 2 times of e raised to power 2x. So this is a 4 plus 2, that is equal to 6 e raised to power 2x minus 6 e raised to power 2x. So that is equal to 0. So that is equal to the right hand side. So left hand side is equal to the right hand side. So clearly e raised to power 2x is also a solution of this differential equation. Moreover, you can check that these two functions are linearly independent. Now, how you will observe that they are linearly independent? One, you can directly check from the definition, and second, we can use a concept of Wronskians. Using the Wronskian, let's check it whether they are linear independent or dependent. Since we have these two functions, so Wronskian in this case, the Wronskian of y1 and y2, that is calculated as determinant of first function, then second function, take its derivative over here. Its derivative is e raised to power x. Its derivative is twice of e raised to power 2x. Now take the determinant, that is equal to 2 into e raised to power x into e raised to power 2x minus e raised to power x into e raised to power 2x. Simplify this, you will get e raised to power x into e raised to power 2x, that is equal to e raised to power 3x. And that is never be is equal to 0. So this implies the functions y1 and y2 are linearly independent. Now if you observe the original equation, in this equation is a normal because the coefficients are constant and the leading coefficient is not is equal to 0. Moreover, these two functions are linearly independent. Therefore, we can write its general solution. The general solution is written as yx is equal to c1 times of the first solution, that is e raised to power x, plus c2, that is the second constant, times of the second solution. So this is how you will write the general solution for the homogeneous differential equation. Let's take another example. So in this case, we need to show that these two functions are bases of the differential equation this. So bases means they are the linear independent solutions. Sometimes it is also called as the fundamental solution. So we need to show that these two functions x and 1 by x are the solution of this differential equation. Let's observe that. So let y1 x is equal to x and y2 x is equal to 1 by x. So if they are the solution of this differential equation, it means they will satisfy this one. So let's take the left hand side for the first case. So for the first case, we will write it as x square y1 second order derivative plus x y1 first order derivative minus y1. So we need to calculate the derivative of this one. So y1 is x. So y1 first derivative, that is equal to 1. Now its second derivative of x is 0, that is the derivative of 1 is 0. So now substitute these values over here. So when you substitute, you will get x square into 0 plus x into 1 minus the value of y1 is x. So simplify this, you will get x minus x, that is equal to 0. Since it satisfies this differential equation, it means yes, y1x is equal to x is one of its solution. Now what about the second one? Whether y2x is a solution of this differential equation. So if it is a solution of this differential equation, so definitely it will satisfy this differential equation. For that, we will take x square y2 second order derivative plus x y2 first order derivative minus y. Now calculate the derivative of this term. So what is the derivative of y2? That is equal to minus 1 upon x square. Second order derivative of this one means take further derivative of this. So that is equal to 1 upon x cube multiplied by 2. Now substitute these values in this differential equation. What you will get? This is equal to x squared. Second order derivative value is 2 upon x cube plus x into first order derivative, that is equal to minus 1 upon x square minus y2 is, this is a y2, so that is 1 by x. Simplify this, you will get 2 upon x minus 1 upon x minus 1 upon x. So you will get 0 because this will be a minus 2 by x and this is a positive 2 by x. So this gives you 0. So this implies y2x is equal to 1 by x is the solution of given differential equation. Now, if they are the solutions, now we need to identify whether they are the linear independent in order to claim that they are the basic of the equation. So first step is we need to identify whether they are solution or not. Then we will identify whether they are the linear independent or not. For that, we will calculate the Wronskians of these two functions. So we have these two functions. Let's calculate its Wronskians. Wronskian is calculated as determinant. So since we have a two functions, so we will get a 2 by 2 matrix. So first we will place the function as it is. Then take its derivative in the next row. Its derivative is 1 and its derivative is minus 1 by x square. So determinant is equal to x into minus 1 by x square minus 1 by x. So this is equal to minus 1 by x minus 1 by x. So that is equal to minus 2 by x. So we have a Wronskian value is equal to minus 2 by x. Now is this value is not is equal to 0 for every real number? No, because this number is not defined whenever x is equal to 0. So we will say that the Wronskian value is not is equal to 0 for all x belongs to the set of real number except 0. So we need to remove 0 from here so that we can claim that these two functions are the linearly independent. So we can say that the function x and 1 by x forms a basic of the differential equation x square y double dash plus xy dash minus y is equal to 0. Even you can observe that this differential equation is normal for every real number except 0 because the leading coefficient is 0 for x is equal to 0. Now, what is the general solution? So, general solution is equal to yx, that is equal to c1 first solution, that is x, plus c2 into the second solution, that is 1 by x. So this is how you will write the general solution in this case. Now there was a second part of this question, that is obtain a particular solution when y1 is equal to 1 and derivative of y at 1 is equal to 2. So now we have two conditions, y1 is equal to 1 and y prime 1 is equal to 2. So this means in general we are writing a function of x, y is a function of x. So this is the value of x and this is the value of y. Same in this case it is a value of x but this is a value of derivative. Alternative way to write this one is at x is equal to 1, y1 is equal to 1, and from here we can say that at x is equal to 1, the derivative value is equal to 2. So we will use these two conditions in order to find the values of constant from here. So let's suppose this is the equation number 2. Now we will substitute x is equal to 1 in equation 2. We will get y1 is equal to c1. The value of x is 1 plus c2. Put x is equal to 1 over here. So this is 1 upon 1. So this implies the value of y1, that is 1, is equal to, this is c1 plus 1 by 1 is 1. So we will get simply c2. So from here we are getting the condition in terms of the constant. Now we will use the second condition, that is the derivative at 1 is equal to 2. So first we need to calculate its derivative. Now what is the derivative of this one in terms of x? So derivative of the first term. So derivative of x is 1. So c1 is constant. We will place it as it is. Plus c2 is a constant. What is the derivative of 1 by x? That is the minus 1 upon x square. Suppose this is the equation number 3. Now put x is equal to 1 in equation 3. So we have in this case as y prime at 1 is equal to c1 plus c2 minus 1 upon, when you put 1 over here, it is a 1 square. So the value of y prime at 1 is 2. So this is equal to c1, so minus c2. Now we have two equations. One is c1 plus c2 is equal to 1, and second is c1 minus c2 is equal to 2. So suppose this is the equation number 4 and this is the 5. Now simplify equation number 4 and 5 to get the values of c1 and c2. So by simplifying equation 4 and 5, we have the value of c1 is equal to 3 by 2 and the value of c2 is equal to minus 1 by 2. Now use these values and put it in equation 2, that is the general solution. So in this case, so this is the equation number 2, that is the general solution. Now put the values of c1 and c2 over here. So final value 3 by 2x minus 1 by 2 into 1 by x. So that is 3 by 2x minus 1 by 2x, and is the particular solution. Basically, in this question, we have performed the three steps. First, we have identified whether these two functions are solution or not. And if solution, we then find whether they are linear independent or not. In order to find the particular solution, we need the general solution. Then we have written these two solutions in form of journal. Then with the help of these two conditions, we have evaluated the particular solution to this differential equation.